This is question 2b. Benzene can be used as a starting material for the synthesis of compounds D and E, shown below. In the diagram, C6H5 is a phenyl group, that's your benzene ring group. Compounds D and E can be converted into polymers. Draw 2 repeat units of these polymers. All right, that's even bolded, 2 repeat units. So if you've only drawn 1 repeating unit in your answer, you cannot get the mark for it. You've got to do what the question is telling you to do. So 2 repeating units from compound D, and then 2 from compound E. So what you've got here is you've got a double bond present between the 2 carbons, and here on compound E you've got an amino group and you've got a carboxyl group. So you can have your 2 different types of polymer forming. Addition polymerization taking place in compound D, and condensation polymerization taking place in compound E. So if we look at compound D first of all, so if we're going to polymerize this molecule, we're going to break the double bond, we're going to form sticky ends either side, and then this monomer repeats itself over and over again. So 2 repeating units will be 4 carbons, all now with single bonds in between them, and then you need your continuation, your sticky end bonds going off either side. Any groups of atoms that are bonded to those carbons stay exactly as they are. So I've got hydrogens on the top, so all the way along the top will be hydrogens. On the bottom, then the first carbon has got my C6H5. Then the second one will have a H, and then that repeats, C6H5, H. Simple as that. You can put brackets around it, you can put your N after it if you want to, but that is the minimum requirement for the answer. And then for polymer E, it's one you have to be more careful with when you're thinking about your condensation polymers. This unit will repeat itself twice, with the removal of a water molecule in between them to form the link, to form the polymer. Now with an amino group and a carboxyl group, that means I'm going to be forming a polyamide. Okay, so polyamide, remember the amide group is NHCO. That is your amide link. So that is what we're looking for in your molecule. So this will be the center of the polymer, and then on either end will be the parts that make it. So you'll have an NH on one side and a C double bond O at the end, on the other side. So we would have, if we start on this side, NH, and that's your continuation bond there. Then the C, CH3, C6H5. Then we've got our amide, C double bond O, and then we're going to link to the next one, NH. And then we start the whole thing again. C, CH3, C6H5, C double bond O, and there's your continuation bond there. Now a common mistake that we're seeing on these ones is an extra O being put in. Remember, when you form the polymer, when you form the amide, that oxygen is disappearing to form a water molecule. So if you put a single bond O there, you're then not making your polymer, your repeating unit correct. That oxygen is not there. Think of it this way, this bond is going to link onto that. So that is your 2 repeating units. And then part 2, state the type of polymer formed from compounds D and E. I've already mentioned this when I've been explaining what's going on. So compound D is an addition polymer, and compound E is a condensation polymer or a polyamide. You could even go for the specific one. So I'll put a slash there. Okay, now the chemistry spec will not accept polypeptide for that, even though your CONH is a peptide link for the biologists. We will not accept that in chemistry. If you're going to have this, you call it a polyamide. Okay.